we're asked to subtract all of this craziness over here. And it looks daunting, but if we really just focus, it actually should be pretty straightforward to subtract and simplify this thing. Because right from the get-go, I have 4 times the 4th root of 81x to the 5th. And from that, I want to subtract 2 times the 4th root of 81x to the 5th. And so you really can just say, look, I have 4 of something, and then this something I'll just circle in yellow. I have 4 of this, it could be lemons. I have 4 of these things, and I want to subtract 2 of these things. These are the exact same things. They're the 4th root of 81x to the 5th. 4th root of 81x to the 5th. So if I have 4 lemons and I want to subtract 2 lemons, I'm going to have 2 lemons left over. Or if I have 4 of this thing and I take away 2 of this thing, I'm going to have 2 of these things left over. So these terms right over here simplify to 2 times the 4th root of 81x to the 5th. And I got this 2 just by subtracting the coefficients. 4 of something minus 2 of something is equal to 2 of that something. And then that, of course, we still have this minus the regular principal square root of x to the third. Now I want to try to simplify. I want to try to simplify what's inside of these under the radical sign so that we can, in this example, actually take the 4th root, and over here actually take maybe a principal square root. So first of all, let's see if 81 either is something to the 4th power, or at least can be factored into something that is something to the 4th power. So 81, if we do prime factorization, is 3 times 27. 27 is 3 times 9. And 9 is 3 times 3. So 81 is exactly 3 times 3 times 3 times 3. So 81 actually is 3 to the 4th power, which is convenient because we're going to be taking the 4th root of that. And then x to the 5th we can write as a product. Let me write it over here so it doesn't get messy. So I'm going to write what's under the radical as 3 to the 4th power times x to the 4th power times x. X to the 4th times x is x to the 5th power. And I'm taking the 4th root of all of this. And taking the 4th root of all of this, that's the same thing as taking the 4th root of this, And let me just, I'm going to want to skip steps. So I'm taking the 4th root. I'm taking the 4th root of all of it right over there. And of course, I have a 2 out front. And then x to the 3rd can be written as x squared times x. So it's minus the principal square root of x squared times x. And I broke it up like this because this right over here is a perfect square. Now, how can we simplify this a little bit? And you're probably getting used to the pattern. This is the same thing as the 4th root of 3 to the 4th times the 4th root of x to the 4th times the 4th root of x. So let's just skip straight to that. So what is the 4th root? Well, I can write it. Let me write it explicitly, although you wouldn't have to necessarily do this. This is the same thing as the 4th root of 3 to the 4th times the 4th root of x to the 4th times the 4th root of x times the 4th root of x. And 2 is being multiplied times all of that. And then this over here is minus the principal square root of x squared times the principal square root of x. And so if we try to simplify it, the 4th root of 3 to the 4th power is just 3. So we get a 3 there. The 4th root of x to the 4th power is just going to be x. Actually, I just reminded myself, we have to be careful there. It is not just x, because what if x is negative? If x is negative, then x to the 4th power is going to be a positive value. And when you take the 4th, remember this is the 4th principal root, you're going to get the positive version of x. Or really, you're going to get the absolute value of x. So here, you're going to be getting the absolute value of x. And then, well, you could make an argument that x needs to be positive if this thing is going to be well defined in the real numbers, because then what's under the radical has to be positive. But let's just go with this for right now. And then we have the 4th root of x. And then over here, the principal square root of x squared, by the same logic, is going to be the absolute value of x. And then this is just the principal square root of x. So let's multiply everything out. We have 2 times 3 times the absolute value of x. So 2 times 3 is 6 times the absolute value of x times the principal, or the principal 4th root of x, I should say, minus, we took out the absolute value of x, times the principal root of x. And we can't do any more subtracting, just because you have to realize this is a fourth root. This is a regular square root, principal square root. If these were the same root, then maybe we could simplify this a little bit more. And so then we are all done, and we have fully simplified it. And if you make the assumption that this is defined for real numbers, so that the domain over here, this what has to be under these radicals, has to be positive, actually in every one of these cases. And if they need to be positive, we're not going to be dealing with imaginary numbers. All of these need to be positive. Their domains are x has to be greater than or equal to 0. Then you could assume that the absolute value of x is the same as x. But I'll just stick it right here. If you restrict the domain, you could get rid of the absolute value signs.